so they're filing in quietly, so I'm just going to go ahead and start. So good afternoon. My name is Victor Krabendam. I'm the LSST project manager. I have the next 23 minutes to give you sort of the logistics for the week and a little bit of a summary about where the project stands. And I can tell you right now, there is no way that I can cover and do justice to all of the activities that we are engaged in the project and all the great advancements and all the great progress that we've made. So I just have some teasers to sort of cover some items. And then, of course, throughout the week, there's plenty of opportunities to engage with the project teams and find out some more of the status, more of the real status, and maybe even some of the issues, and to be able to talk to them and engage with them. So that's really how we've sort of structured this week, and really hope that there's lots of opportunity for engagement. So before we get started, if you saw the digital signage, has a much nicer slide on this than I have. But welcome to Tucson. This is a nice resort we have here, but this is the desert. And so I am obliged to tell all of you, especially from the Northeast, that are used to humidity, it's warm here. And if it's not warm, it's air conditioned. And in both those cases, you need to stay hydrated. And so I really think actively about drinking water, particularly if you're starting to feel weak, fatigue, headaches. Those are classic signs of dehydration. And drinking water is a good start. Also, welcome to the desert. We have lots of cool wildlife. And also, if you're from the Northeast, by the way, that's where I'm from. And so I know that when you see things like javelina and you see coyotes and rattlesnakes even, you like to go look at them, but really you ought to keep your distance for obvious reasons. Okay, and then the last thing is this is monsoon season for us. And so if you're lucky, you will have some great opportunities to witness what we love to see here is some rain and some storms, but you really do have to respect that water because it floods, it rushes, and for moments of terror, there can be lots of water right near where you are. And then, of course, lightning. And when it's not raining, then we have a pretty strong sun. And for that, we actually have some sunscreen out at the resource desks to make sure that you stay protected. All right. So we have a great agenda this week. There's lots of places where you can see this, preferably online, where you can see all the details. But most importantly, at this moment, what I really wanted to do was thank 3 significant organizing committees that make this happen. It starts from right to left. I'll point out that Melissa Graham ran the Science Organizing Committee, really focused on what the project, how the community would like to engage with the project. The Program Organizing Committee, led by Rampal Gill, she really kept us to task and made sure that we integrated what the project can do, what the community was interested in, and made sure that we came up with the agenda that we have today. And then the Local Organizing Committee makes all of this work. There's a lot that goes into this to make a meeting. There's over 330 of you registered, lots of logistics, lots of rooms, lots of things that have to happen behind the scenes. And to these people, I extend my deepest thanks for making this happen. And it really does take all of these people to make it work right. If I was clever, I'd have had them stand up, but we got their pictures, so maybe you can see them. Also, I'll point out to you, if you're careful and you look at the badges, you can actually tell who's in which organizing committee. It's not real obvious, but there's another way to tell. Okay, so a few general items of logistics. First of all, if you use Slack, there is a Slack channel. It's monitored by Rampal and Daniel in particular. That's a great way to get some help. To get any issues resolved, to just get answers to whatever questions you have. And so I encourage you to get onto Slack for that. If you're a little bit more old school, you've got email. And if you really want to, Rampal, would you like to stand for a moment? You can find Rampal. She's all around. She can help you. Daniel, you in the room? Daniel is not in the room. Oh, there's Daniel. Daniel can also help. Those are the 2 people in that organizing committee that are available to meet and try to meet needs and requests. Take a look around. This is going to be a good venue. If you're used to some of our other ones, we've had different multiple levels. Now we're all on one floor. Hopefully that'll allow for some good engagement between the various breakouts. But also always keep in mind where you are because we do have emergencies, and it's always good to know where your local exit is depending on which room you're in. And so a couple other logistics. You've already figured out that this room has no power cords. So you're left to either your battery or to listen to the plenary speaker. It's a novel idea. And so this room doesn't have it. All the breakout rooms do have power. We do expect there to be some working sessions there, and we recognize that burning some CPU time would be good. I'm going to talk to that first bullet about being filmed. We're going to talk about that at the very end. I will say that we are filming all of the plenary sessions. We are also broadcasting on Blue Jeans all of the plenary sessions. And so if you're on Blue Jeans and you're listening to this, we also have people monitoring the chat window of the Blue Jeans session if there are questions that you'd like to transmit, and we will get them asked for you here in the room. We have a nursing room. You've already hopefully seen the hashtag on the bottom left corner, the LSST2018. So presenters, in the breakout rooms, you have to bring your own laptop. You need to be able to connect to the projector. So bring the dongle that's appropriate to your laptop. If you do want to use Blue Jeans in those rooms, there's a Blue Jeans connection identified, but it's up to you. We really focus this meeting to be on collaboration in person. And so we do recognize that some people can't make it. We'd like their participation in a session, but we really did not focus on making sure the IT resources were there for real significant remote collaboration. So that's why there's very little support for that aspect in this meeting. But if you want it to be part of your breakout, if you want to use that remote connection, then please take the initiative and work that out with whoever you're dealing with remotely. And then closeout slides, last bullet, sorry. We do have a closeout session at the very end. We would love to hear a minute or two from every one of the breakouts about what status, about what came out of your breakout, what kind of conversations you had. And so there is a file already developed in Google Docs that you can load, you can look at and start to put in a slide or two that captures the results of your particular breakout. So we do have a resource table you saw next to all of the registration items. Those people are, we have a list of people that will be there. There's that display showing who's going to be there and when is available, and you can kind of tell. We have some people from IT, we have some people from communications, compliance, have some times that they've volunteered to be at the desk so that if you have a particular question or concern, want to have a conversation with those particular parts of the project, please come by that resource desk at the prescribed time for the timetable. And then in particular, many of you traveled here, and so Erin is available. She has her own desk to handle any travel questions that you might have or travel issues while you're here. Okay, when you registered, we were also pretty careful this time to make sure that there was a code of conduct. I really encourage you to look at that code of conduct and understand what we're trying to put forward there. In particular, sort of the four sort of classic items about being kind, inclusive, try to trust each other in what we're doing, and most importantly, just respect the people that are here. Everybody has an opinion when we're working in these working sessions, in these breakouts. We really would like to hear from the various corners of the project, of the community, and so we really would appreciate if everybody allowed for that inclusivity. There's also a session, I think on Friday morning, just about some of the code of conduct in the project in general. Okay, so the agenda, again, here, you can't read it. It's online. It's also posted outside. And, but let me point out a couple of items starting today. So today at 5 o'clock after the main sessions, we do have a poster session that is going to be forecast for us by some student guests that we have about the work they've been doing. And so that's a nice opportunity to see how this particular group of 19 people are starting to interact with LSST and to think about the science they want to do. Tomorrow, I want to point out that Barry Barish and our own Leanne Guy are going to give a keynote talk in the morning, talking about some of the results, lessons learned, particular from LIGO experience and from Gaia experience. So for the plenary session tomorrow, I'll look forward to those two talks. Also, Tuesday, we have a group photo. So that's going to be two group photos. We need a group photo for Women's Day that happens, I believe, in March. It's probably on the display. And in the past years, we didn't have our photo. And so this year, we want to make that photo. So when we're taking the group photo, there's going to be two, one for women, and then the overall, the whole group photo, all 333 of you. And what we encourage is for everyone to wear that nice shirt that you got. It makes it sort of kind of a one color picture, but it's kind of fun to see everybody in their LSST t-shirts. If you have accessibility issues, please let us know. The map of where it's going to be is also on the digital signage. Also tomorrow, reception, tomorrow evening at 6:30. It's a little bit of a walk from here. There's a shuttle to get you there if you need it. Otherwise, they plan on about a 5-minute walk. And we can also accept guests, but part of the registration fee covered the cost of the reception. So if you want to bring an extra guest, just let us know so we can, by the end of today, so that we can get them accounted for. All right, Wednesday, there's a nice little idea that the EPO and communications team have come up with, which is the story time domain. And so you can sign up for a slot and go into this little, I don't even know what you want to call it, a little pop-up area, and tell your story. And so they'll videotape lots of stories. They're really interested in getting some of the stories from the group, from the project, from the community, just everything that sort of surrounds LSST. And so for 15 minutes, you can tell your story. And so look forward to seeing people sign up for that. It will start on Wednesday, goes through Thursday, and so there's lots of slots you can take. Also, notice that on Wednesday afternoon, we're also doing an unconference. And so that's your opportunity to put some ideas and some topics on the board. And the top topics will be picked, and we'll write down your ideas and separate out into groups and have some breakout sessions, some impromptu breakout sessions in that fashion. And then Thursday, we have a great public lecture. Artis and Phil are going to highlight and give us a talk, and that's going to be open to the public. So at 7 o'clock, I believe in here, probably maybe even extending out, we will have that talk. We've sent out lots of invitations, lots of media coverage has been put in place so that the local Tucson community has been invited to come and hear about exploring the final frontier with LSST. All right, and then Friday, there is, I don't know what alternate location for breakfast means, but you can read that as well as I can. And then grab-and-go lunches. So we'll end the conference at lunch. We will provide you some food, and then we'll be basically at the end of the formal conference. The rest of the afternoon, we have rooms available, but IT is going to be starting to clean up, and so IT resources won't be available, and so nor will some of the support staff because they have to start really getting cleaned up here. So if you want to have a space, you want to keep meeting, just let us know. We'll make that possible. All right, final comments. Stack Club tutorial. If you want to be part of that, you need to register, and there's a shortcut to get to the registration page, and you can start there. I already mentioned that plenary speakers we are recording, and we will be putting these talks up on YouTube, on our LSST YouTube channel. Another item, if you've been involved with the project for a while, you know that every 6 months or so we do a day in the life, where we invite anybody in the project that's working on something to just snap a photo and send it in and tell us what you're doing. And so you'll see online right now in the gallery, you can already look at some of the slideshows that are kind of fun to see, just the people, what they're doing in all corners. And remarkably, there's an awful lot of telecons and videocon pictures in those slideshows, but also lots of really neat hardware. Every morning you can expect to hear some of the day's announcements. If you have an announcement you'd like to make, please let us know. We'll make sure that that's made in the morning. And then also we have digital signage. If you saw it when you were walking in before we started projecting this slideshow, the digital signage is projecting some of those announcements as well. So now I just really wanted to go quick and just tell you there's no way that I'm going to cover it, especially having already used 18 minutes of the 25. And so technical progress on this project is excellent. We are 56% done as of the end of May, or at the beginning of May, we were 56% done on the MREFC, that's the NSF side of the development, and 82% done on the camera side. And so this project is moving along at a rapid clip at this point. Lots of things coming to a conclusion. Lots of, the end game is really coming into focus. We do continue to encounter problems and challenges. Those of you here that are working in the day-to-day project are probably working on integration activities or completing certain prototypes. And so in that process, we face challenges. And what's really been exciting is that every problem that we've had, we've solved. And so sometimes we needed a little extra time, sometimes a little extra money. But in every case, every technical solution, every technical problem has been resolved. So overall, we have used another 2.5 months. Last year, we probably talked about having used 2.5 months of schedule contingency. We've used up another 2.5, so we're down to 8.5 months of contingency on the camera side. It's still, or on the overall project, and telescope is still the critical path. Camera is running neck and neck. If you're racehorse fans, you can't call this one yet. And so we're trying to watch that. We're working with both Bill and his group and Vincent and his group to try to make sure that we stay on top of the schedule and make sure we're dealing with it as best we can. And again, we're dealing with the challenges and the risks as we go. So this is slideshow time. This is what we set off to build on the summit of Cerro Pachon. And last year, we would have shown, well, last year, we would have shown that picture being done. And right now, this is the completion of the lower enclosure. And in fact, if we showed a real recent picture, then much of this framework for the dome is actually filled in. And although that's going a little bit slower than we had hoped, it's moving along. And in fact, at this point, I think you can actually see the final shape in the steel structure. But most importantly is that the fixed building is done, and it's been a long haul. Kudos to the site team for getting us to that point and getting it closed up. Top left picture is an inside view of the maintenance area getting ready for the coating chamber, which is sitting actually probably off of a barge in Antwerp, Belgium. It got shipped on barge from Germany to Belgium, is waiting the ship that's going to take it. Get this, the USS Arizona or US Arizona or something is going to actually take it from Belgium to Chile. And then some pictures of the calibration work that's also going to calibration telescope coming together on Cerro Pachon as well. And again, I can't show you all the pictures, but this one I can. This is just a video of the test integration, the factory integration of the telescope mount. This is obviously cell phone video, 10 seconds of it, but that is what's going on right now in Spain as we complete the factory integration and test of that very nice looking machine, getting ready to start taking it apart starting in the end of September. Base facility, you've seen in the past some pretty pictures, some renderings of what we're trying to build, and it's coming together as well. For many of you, what's really key is starting to close up the data facility in the base facility, at the base in La Serena. So, and then if you move over to the camera, boy, those the sensors continue to come in. Over 264 have been delivered, and we only need 208. And so the best ones are the ones we're looking for. 12 rafts have been assembled. A raft, if you'll recall, is 9 sensors. And so at 12 being done and accepted at SLAC, that means we have 1.6 gigapixels ready to integrate into the camera. More of those rafts are in progress at Brookhaven. And again, if you want just sort of see the status of 12, we need 21 plus 4 rafts. So we're well on our way to getting this work done. The integration team at SLAC has been really busy in the last 6 months, filling up the integration hall with all kinds of good test equipment, with the bench for optical testing, and a mock-up of the grid, some mock-ups of actual rafts, and working on insertion tools, making sure that they know how they're going to get those rafts in place. And better yet is that the actual raft, the cryostat itself, is ready for integration of rafts. And in this picture, just last week, they put the first mechanical test raft in the actual grid. And so that is moving along at a really good clip at this point. Some really good progress there. And then the shutter also made some significant advancements last week. This is actually test shutter blades, but the whole system working at full speed, and just a fun image and great representation of some long efforts and good progress there. Okay, shifting over to data management. There in the last year, lots of great progress moving sort of the vision for the science platform that we were talking about last year, and really bringing that into reality with some good prototypes and some good status, with some tools for actually engaging and visualizing the actual data. The software and algorithms are already in use. We can't say this enough. I think we've probably already shown this picture before, and I think we've invited at various talks some of the usages of the LSST pipelines on HyperSupreme data, and this is just a demonstration that we're not talking about software that's going to be built and going to get used. It's already in use at various levels of performance, which is also a great sign towards progress. There's also a lot of work been done in the last year, in particular, on actually getting the connectivity between Cerro Pachon, the summit, and NCSA in particular, and then branching out to France. And so this is just, again, a nice representation of some hard work getting from the main highway up to our site through cables that we had to run, and then the successful negotiation of all of the protected networks that are now in place to get the data up to NCSA. So this is just a really quick picture, just 3 that I could grab easily and quickly. Is just a moment for me to really emphasize and thank the team for spending a lot of time and a lot of effort, particularly this last year, in collaborating, working together. The joint technical meetings that we had, this is a picture here of the data management team working with the systems engineering team at one of our joint technical meetings. On the top left, this is one of the work meetings. I think Chuck is going to show that picture again. A workshop that was being done to use the science platform and learning how the commissioning team was going to be engaging with that. And then a lot of early prototype work that will be the subject of several of the breakouts. And then again, EPO has really come to life in the last year as well. Last year, I think we were starting to get some good ideas. They were heading into a big review of their whole system. Since then, lots of prototypes, not just of websites, but also of notebooks, and actually bringing information to the classrooms, and then getting that evaluated. And so when Wednesday, when Amanda talks about the status, she'll really give you an opportunity to really see the kinds of things that they're doing and how they're getting those prototypes developed and what their vision is going forward. All right, and I can't do all of that status without saying that I really, really, really appreciate that, particularly in this project, from the designers all the way through the implementation, people on the various sites, and the safety crew itself, that we've been able to do all of the work we've accomplished so far with an incredibly good safety record. And almost don't want to say it too loud. I'll knock on this wood right here, because it's almost It's just phenomenal. And it really comes down to a really great safety culture, a really good attitude of the entire team, and the ability to cooperate with those that are looking over and trying to make sure that we do things safely and get things accomplished. I think one of my last slides here now is just to give you the representation, the cartoon of the schedule. And so I've said that we only had 8.5 months of schedule contingency. You can study this later if you haven't seen this slide before, but basically you're looking at data management going along, getting some things done, and dropping work into the commissioning activities in purple. Telescope team doing the same, camera team doing the same, everybody working towards getting their deliverables in place so that the commissioning team can build this system, put this whole thing together, get it integrated, get it tested, and then do some science validation in the end. And these red lines represent the fact that the camera team and the telescope team are both neck and neck on critical path. Okay, so that was a blitz through technical progress, but what I wanted to do at this point is I already indicated that we are recording the plenary sessions, but I also wanted to invite Allison Rose up, and she is an independent film maker, and she is going to be here this week. She's going to tell us here for a moment what her idea is and what her vision is and what she's working on. She's going to be around and was really interested in getting some. That microphone is live.
Yeah, I believe the podium might be live.
So you can speak. She didn't make that chart. I did. I just grabbed stuff.
It's the first time I've ever that anyone's ever made a slide of me.
Oh.
It's an honor to be here. My first film, Galileo's Sons, I shot half of it in Tucson. It's a film about the Jesuits at the Vatican Observatory. And I wanted to think about how one could reconcile faith and science. And my most recent film is Star Men. I followed 4 people that you probably all know: Donald Lyndon Bell, Wall Sergeant, Nick Wolf, who toured me through the Mirror Lab the first time I went to the Mirror Lab, and Roger Griffin. And I have an interactive website called interactivestarmen.space, and Starmen is on Netflix. And when it was introduced most recently at Royal Albert Hall by George Efstathiou, he said, I knew Wall and I knew Donald. And it's really poignant to watch this film again. I haven't been able to watch it. He described what the film does, and then he said it's really a film about the human condition. And that's what I'm trying to do with my films about astronomy. I'm trying to make films about people doing astronomy. Not films about things, but films about us, asking questions, and the creativity that you bring to bear to answer those questions. And so my aspiration, I met people involved in the LSST when I was touring with Starmen. Michael Strauss invited the film to screen at Princeton. And it also screened here for Nick Wolf's 15th, his 80th birthday on the 15th of September. Sorry, I've lost my train of thought.
What are you thinking about?
It's screened at the AAS, and someone from the LSST came to me afterwards and he said, how would you like to go to Chile every 6 months for the next 5 years? And I thought, this is too good to be true. But I was hired by the LSST to go to the summit and film construction workers. Well, I was hired to film the summit, and I said my proposal would be to film the people doing work on the summit. So we filmed the construction workers, and we got a big heavy-duty drone, and we shot the summit in 4K, and we shot the building in 8K. But that was the LSST's idea. Anyway, that's how I learned about the LSST. And my aspiration is to make a film my aspiration is to make many films about the LSST, But to start with, I'd like to make a film about you building the LSST. I'd like to follow you now and over the next few years as this all comes together. And I'm doing some filming now so that I don't miss too much, while at the same time I raise financing to go into full production. And I want the film to be engaging and intimate, and I want people to get to know, I want audiences to get to know people. And so I'm seeking out a few people that will follow closely so that you get a sense of the camaraderie and the teamwork that goes into the kind of problem solving you need to do in order to achieve this, achieve your goal. I'd be happy to answer any questions that you may have about my process. I'll be fully open with you, as open as I can be. And what I'm talking to Steve about now is making a film that would be released when the telescope has first light.
So the only other comment to make here then is, thank you, Allison, appreciate that, is that we recognize that some people, we want to recognize everybody's privacy, and some people may not be interested in being on film. And so Allison has been very careful and diligent about trying to recognize those situations. And one of the things that we've done is, if you are in that category and you just assume not be filmed, you can go to the registration desk and get a red dot and put it right on your ID card, and she'll do her best to just not videotape you if you're part of those conversations. If you're speaking to anybody that is being followed in particular.
Also, with the red dot, the editor, when we're editing, we can see the red dot and we know when we'll cut around you. So the red dot is a really useful tool. You could wear a red dot for now, and when you learn more about the project, you could take the red dot off. But please don't hesitate to put a red dot on if you're ambivalent at all. Thank you so much.
Okay, thanks.
So let me introduce myself. My name is Chuck Claver. I'm the systems scientist for the project. I'm also the lead for commissioning. Many of you know I've been around the project for a long time. Tony Tyson and I first scribbled some stuff down with Roger Angel and Peter Stripmatter and Sidney Wolf back in 1998. And I've been kind of doing this ever since. And so I've got only a few minutes here to talk about system verification and commissioning. You've heard me talk about this before, where you've heard me drone on about various plans, how this thing's going to unfold. And so in the short time that I have today, rather than go over all the plans that we are putting into place, I thought I'd highlight the things that are already started. There we go. All right, so you saw this picture from Victor. We've talked about in the past that this year has been sort of a sea change as far as I'm concerned as it relates to commissioning and system verification. And in that, we're here. It's started. It's happening. It's no longer a thing in the future. We often talk about commissioning only, starting. We often hear about it here, starting a couple years from now, but in truth, it's already started. Things have already happened. So I'd like to just highlight some of the things that the commissioning team and the system engineering team have been doing, and some of the milestones we've accomplished over the last year. So this is the classic systems engineering V diagram. We've been going down the left side of this diagram for quite some time now. That's the design, the definition of requirements. We've been in the build phase for a while as well, and now we're starting to crawl up the other side of the V. And we are here. Things are coming together, which is really, it's really exciting to see that. So here's an example of what I mean by what the verification process that's already underway. This is an example of an interface verification. This is a a diagram that we borrowed from the camera team showing the various interfaces of the system. This particular one that I highlight here is the camera telescope utility interface. And those numbers up here are the documents that govern that interface. But we start off with some models, ideas, and routing the details. That's the interface that we're talking about here. That's the bulkhead plate on one side and the wobble plate on the other side. We've worked out all the details, drawings, specifications, dimensions, etc., and now it's become real. All right, so this is the inspection of that utility interface at the TMA vendor in Spain. The TMA vendor delivered to the camera team at SLAC a copy of this plate right here, which is there, and then the camera team has built up a mock setup of the routing of the plumbing to verify that both sides of this interface are going to mate together and work as planned. And all of this ends up inside this piece up here, which is the camera cable wrap on the telescope mount assembly. And Victor mentioned a bit of it, is that we are in final acceptance testing at the factory for this whole telescope mount. There's been a very heavy presence over the last several weeks of many of the project people here in Tucson in particular going back and forth to Spain. There's a whole bunch of us going right after this meeting out to Spain to continue that verification process. And so things are becoming real. And by the end of September here, we expect this system to pass its acceptance test at the factory and then get taken apart, put on a boat, and shipped to Chile, where it then gets reassembled. There was a breakout earlier today to kick things off here about early integration activities. These are activities where right now it's primarily a software focus, where we're looking at command and control of the OCS, TCS, CCS, so that's the observatory control system, telescope control system, camera control system, data management interfaces, et cetera. And this is being organized by Michael Reuter. This is a series of activities focused around the instrument and the auxiliary telescope. There's a similar set of activities focused around the main camera. So going forward, we have a number of these milestones where we're bringing together systems from all three of the technical subsystems together in one place at the same time and bringing the right people together to validate and verify that those interfaces are being carried out as we expect them to. This is an example of a recent activity. So you saw this picture in Victor's slide deck. So this here is the spectrograph for the auxiliary telescope. And we have members of data management, systems engineering, telescope and site, camera. They all came together in Tucson just a few weeks ago and got their systems to work together and started working on the transfer of image data from this instrument into the data management system using all the same interfaces that will be used by both ComCam and the LSST cam. And this is an example of a test image from the auxiliary spectrograph here. That's a zero order image there, and you got plus or minus first order spectra coming out. And this will be used to characterize the Earth's atmospheric transmission as we go forward. So it's all good. I mean, it's a huge amount of progress is being made. And I can't stress enough, and I know many of you would agree, that bringing the systems together early and frequently and just trying to use them will pay dividends that we can hardly imagine when the real system comes together down in Chile. So part of the commissioning plan for LSST involves something we call ComCam. ComCam is a single raft camera. So that's 3x3 4K sensor, so that's 144 megapixels. This will go on the telescope before the main LSST camera goes on to do some early verification. ComCam, as you see here at the SLAC IR2 clean room, is coming together. ComCam uses all the same hardware, software, command control interfaces as the main camera, so this will be an important pathfinder for us. Here you're seeing one of the engineering rafts. Can I borrow your light? Thank you. One of the engineering rafts developed at SLAC here being put into the ComCam Doer. I think this was just a matter of a week or so ago, and it'll start undergoing some electro-optical testing. This is the filter changer for ComCam. So ComCam will have 3 filters available at any given time. To date, we have 4 out of the 6 LSST filters in hand now for ComCam. So we have G, I, Z, and Y. And so this Doer is going to be delivered to Tucson this February. And then between February and July, it'll be in the lab in Tucson here undergoing integration and test. And this, again, will be a point in time where we're bringing together the camera control system, the data acquisition system, the telescope control system, the observatory control system, and the data management, I think it's the data archiver that accepts the data from the imager here and then pipes it off to NCSA. So this is happening early next year. By August of next year, ComCam will be ready to ship to Chile. It's well in advance of when we actually need it in Chile, but nevertheless, it will be ready. And by that time, we will have tested a great deal of the interface infrastructure needed to run LSST as a complete system. Another big deal that happened over this past year is that with Will O'Mullane, the data management manager now in Tucson, and now recently Leanne Guy, the data management scientist, it really has allowed the Tucson team and the more extended commissioning team to really get engaged with data management and interacting with them. So over the past 6 months, 9 months, the commissioning team has been working to develop the tooling, the software tooling that we're going to need to have in place to actually look at the data and analyze it and understand what's going on with the system as a whole. And so here's some examples of some interactive tooling that we've developed. The LSST science platform has come to life. You see an example here. This is showing using some legacy data, the properties, some shape properties of galaxies versus magnitude, using the science platform. This is, was a big hurdle for the data management and the commissioning team this year to start directly interacting with the proto data platform, or science platform. You saw this picture from Victor. I won't dwell on it. Again, these are example of notebooks that the commissioning team is using to help develop their processes and our analyses and prototyping them with legacy data. We held a workshop where data management team members and the commissioning team members all got together in the same room. We spent several days in real time developing some prototype scripts and just learning how to use the science platform and the DM stack. Another effort that's been going on within the commissioning and the systems engineering team is work, again, this is Michael Reuter's work, where he's working with the Square team here in Tucson to extend their squash tool, which is, this is just a screenshot showing this is a test data set. But this is, we're working with the Square team to extend squash to be a repository of verification test results. So as we go forward, as we verify something and we continue to re-verify it and monitor it, we will use this tool as an interactive tool to monitor its status. And this just gives an example where you have some data here. The tool shows you, individual data points. And when an individual data point is actually an aggregate of a larger body of data, you can then interactively go to the origins of that data and actually look at it at a granular level. And so we're using this, or planning to use this, as a means for capturing not just the scientific performance metrics, but also the technical performance metrics. So the systems engineering team has been working with DM to extend this tooling into the technical domain and not just the science domain. And lastly, I'm getting close to the end here. Keith Bechtel and company have been working to figure out during commissioning what our data plan is going to shape up to be. And this is an example of how we've blocked out the commissioning time. So the column is early verification with ComCam, ScienceCam, and then the final validation mini surveys. And in both the LSST-Cam and ComCam, there's roughly a 3 to 4 month period where we are really focused on the technical hardware-oriented integration. And those are followed then by these blue blocks of time that are really geared towards acquiring data for the specific purpose of stress testing the science algorithms. And Keith has been working with the science validation team to identify various places on the sky where we have some form of truth that is known, so that we can compare that truth with the similar result that we would get from the LSST data, and that will help us validate the performance of the science pipelines going forward. So lastly, I know people from the community, I get questions asked of me all the time about how and when will commissioning data be made available. And so I wanted to summarize where we have landed as far as what our policy is. So the construction team itself is not able to and not scoped to make the commissioning data generally available to the community. However, during the same time during commissioning, early operations will be ramping up. And that early operations team will commit to supporting the release of commissioning data under the following sort of constraints. So images from any given commissioning phase will be released after 3 months following that phase's conclusion. And then the catalogs related to those images will be released 3 months thereafter. And so at the end here, I listed what are those primary phases where some interesting data may become available. So we have Oxtel integration. That's actually starting fairly soon, March of 2019. So sometime a month or so thereafter, hopefully we'll get some data. ComCam goes on the telescope in July of 2020. LSST-Cam arrives in Chile in September of 2020. And while we're re-verifying LSST-Cam, we are entering the sustained observing with ComCam. Those are those 3 1-month blocks that were on the previous chart. And then LSST-Cam goes on the telescope, and we eventually get to sustained observing with LSST-Cam in July of 2021. And those operations readiness mini surveys get started in September of 2021. So these are all subject to the 8.5 months of schedule contingency that we currently hold, but this is our current schedule for these are what I call the commissioning data release milestones. And so I think the message I'd like to end with then is to remind you again that commissioning isn't some sort of fictitious thing out in the future and we're waiting for things to show up and get started on. We're starting on it now. There's a lot of preparatory work that has to get done, and you can see by this schedule here, some data is going to start flowing in the not too distant future. These dates are not that far away. And with that, I will pause and take questions. No questions. Perfectly clear to everybody. Question over there.
The commissioning plan, the phases, will that be made public? What's the timescale for that?
The commissioning plan as a document is available.
Okay. And the fields and everything, I mean, like everything that's going to be...
So we do have fields selected now, right? But given the ambiguity in the schedule, it's a little hard to nail them down exactly what fields will get observed when. Come see me during the meeting here if you have inputs on specific fields. I think something I should have mentioned during the talk is that I'm around all week. Come talk to me if you have ideas or inputs that you would offer up. So by nature, right, during commissioning, because a lot of things are going to evolve with time, you have to be pretty flexible about exactly what you do.
But are you going to sort of have a rolling, like long-term or short-term schedule that will be sort of updated?
Yeah, so the planning strategy is once commissioning is underway, we will kind of every month review the past month's activity and then look forward 1 more month and 2 more months out. And that will always be publicly available as to what that schedule looks like.
Thanks.
One more? Hey Dara.
Chuck. So my question is commissioning data. So usually you'd have a science verification. Is that wrapped up in commissioning data? Are they separate? Is it all part of the same thing?
Oh, never mind. So at the end of commissioning, we currently envision that we're going to run what we call our science validation mini-surveys. So those are 2 mini-surveys that are designed to, one, stress the alert production, and then the second one is designed to stress the 10-year data release processing. So those would be, in essence, the science validation data sets that would eventually become available.
Yeah, so when you talk about commissioning, you mean all of that?
Yes.
I mean, yeah. Okay, thanks.
Other questions? Nope.
Okay, I can start. So good afternoon, my name is Bo Shin. I am Deputy System Scientist, and I also lead the commissioning system integration effort. I'm here to give you a short summary of LSST performance prediction. Short summary is all good. So, yeah, first, just to set the context. So we need to make sure the system we build will meet the science goals. So there is this complex interplay between the system and the science. So any science program would depend on numerous system parameters, and going the other way, so any system parameter would impact numerous science programs. So the way we quantify the interplay between system and the science is to have the science requirements. So this is where the science requirements document comes in. Then, so flowing down from the science requirements document, that's the SRD. So the document tree you just saw, that establishes the project requirements traceability. So at the top level, you have the SRD, the science requirement document. And then the science requirement document is, of course, the highest level. So it is the LSST board approved document. The current version was formally adopted in 2011, and it has been unchanged since that time. And below that, all these documents are LSST product controlled. So more accurately, we have the change control board. Everything has to go through the change control process. Just one slide on the basic approach we take for performance tracking. So we as a project has continuously maintained our best estimates of the system performance. In early phases of the project, so we had to rely on a lot of simulations because we did not have any as-built data. But as we get deeper and deeper into construction, we have more and more as-built information as we have the hardware. We put those information into the simulations, the models, so that we can improve the fidelity and better estimate of the system performance. We are in a process of establishing a more formal performance baseline tracking mechanism. So we will use a combination of different tools like Magic Draw and GitHub with Python code and Python Jupyter notebooks. So we will produce a formal document that describes that process, and this document will be change controlled. The plan is the project will have a new performance baseline pushed out to the community every 3 to 6 months on that schedule. So coming to the performance metrics we track, the major metric is the integrated 8-ton deal. So we know that the 8-ton deal of an optical system is the product of the collection area and the field of view. Then once you put in the integration time, so you have the integrated 8-ton deal. Basically, this is a quantity that controls the total number of photons captured by the LSST system. It is a really useful metric because most of the science metrics scale linearly with the integrated 8-ton deal. So you can write this equation here. The integrated 8-ton deal is a product of 3 things again. And these nominal values, these are the values as defined by the SRD. Then if you move these nominal values to the other side of the equation, you can have the dimensionless form of the integrated 8-ton deal. That is what we call the F product. So the F product is the product of the fill factor FF, the sensitivity factor Fs, and the observing efficiency factor Fo. So before I go further into more details about those factors, I want to use this chart to show you the big picture about the performance metrics we track. I already talked about the integrated 8-ton deal and the 3 F factors briefly, and then they rely on a bunch of other metrics as outlined here, and also on the top level, together with the integrated 8-ton deal, we also have the image quality. So you may have noticed that the image quality appears in 2 places in this overview chart. That is because the impact of the system image quality on the system performance is twofold. So on one hand, image quality affects the signal-to-noise ratio. That is your ability to do photometry. On the other hand, the image quality is a measure of the image resolution. For example, when you are talking about how well you can resolve your galaxy, so for weak length studies, you care a lot about the ellipticity. In that sense, this is about how well you can resolve your galaxy so that you can measure the ellipticity to sufficiently accuracy. And I also want to note that, so by tracking these metrics, we are not trying to be comprehensive. What that means is, even if we can do really well with these performance metrics, there may still be other science programs that could fail. So we are not trying to track everything. Instead, the goal here is to have a small number of important performance metrics we can, as a project, track, monitor regularly on a regular basis. So we always have a good grasp of the overall health of the system performance of the integrated LSST system. So coming to a little bit more detail to these F factors, the first is the fill factor. So it is defined as the effective geometric field of view area paved by the sense pixels and normalized to 9.6 square degrees as defined by the SRD. And given the current plan of having 13 E2V roughs and 8 ITL roughs given these pixel dimensions, so the current estimate of the fill factor is 0.99. Then we have the sensitivity factor. So this is a generalization of the simple collection area. So it is more about a quantum efficiency-like quantity. So it is like the overall throughput of the integrated system. That is the sensitivity factor. It is linked to the detection limit, how faint you can go, what we call the M5. The M5 can be further decomposed into system sensitivity and observing conditions. So the system sensitivity depends on the collection area, the system throughput, and the system noise, etc. And the observing conditions include a few other things. Specifically here, this theta is the system image quality in the sense of quantifying matter as a measure of the signal-to-noise ratio of photometry. So given the current estimates of the read noise, so Victor mentioned that we have 12 out of the 21 raft accepted already, and also other inputs are the image size, the throughput, also the sky brightness model. So the current estimate of these single visit image depths, these M5 values for each band, they are given here, and the current estimate of the sensitivity factor is 1.03. The third factor is the observing efficiency factor. So this is the total open shutter time normalized to the time required to meet the SRD specification. So the current estimate, we need to survey 18,000 square degrees of sky, and each field of view is 9.6 square degrees. That is 1875 field of view, and we need to visit these 825 times. So that requires 1.5 million visits. The latest OpSim run produced 2.4 million visits with 86% allocated to the main survey. So that gives the current estimate of the observing efficiency factor to be 1.3. So coming to the image quality, again, the impact of image quality on the signal-to-noise ratio is accounted for in the integrated 8-on deal. So in terms of this image quality error budget tree, this is more about the image resolution power. The as-built items are highlighted in yellow, and all the major components have either been fabricated and accepted or close to final acceptance. We see that on both the telescope side and the camera side, we still have margins, and at the system level, we maintain the image quality estimate, the delivered image quality estimate of 0.72 arcsecond. So just a few quick slides on the tools we use to do this performance tracking. So we collectively refer to these tools as the integrated model. We put together this model a few years ago, and since then we have continuously been updating the model to include the most up-to-date as-built information. And this shows the overall structure, the diagram. For the integrated model, you have the yellow, which is the outside input, and the blue, that is the hardware, including the structure and the optics. And the orange stuff, that's all the control. So it's an integrated model because it is a joint simulation of optic structure and the control. So one slide, just to give some highlights on these simulations. So we have been able to close the active optics simulation loop for both the LSST camera and the commissioning camera. The LSST camera is shown on the left, and these are for the commissioning camera. And these in the middle simply shows that we've been including a lot of as-built information. In this case, this is the M3 surface as measured by the interferometer, and we also have things like the L2 transmitted, that's the second lens in the camera, transmitted wavefront error map. These are all included in the integrated model to do all these performance evaluations. And also we've been thinking about failure modes. So what could fail? This particular example is about a broken actuator for the M1, M3. So what happens when an actuator breaks and how the control system is going to respond to that, including the force balance control system, the active optics control system, whether we would still be OK with the image quality, what kind of measures we would need to take in that case. So that's the kind of things we've been thinking about. So I measured GitHub briefly earlier. So this slide is just to use throughput as an example to show how we've been using GitHub to track performance estimates. So we've been using GitHub repository to track our best estimate of the throughput for quite a few years. So we have this project-controlled, system engineering-controlled GitHub repository where we have all these latest estimates of the throughput for each optical surface. And that same GitHub repository also has a code to aggregate the total system throughput from the individual surfaces. And again, as we update the throughput estimates, we continue to monitor the metrics, and we compare to the specifications on a regular basis. So that is my summary slide. So we've been regularly tracking a number of performance metrics, including the integrated 8-undo and image quality. We are doing pretty well on these metrics, and we are establishing a more formal performance baseline mechanism, and we will push out updates to the community every 3 to 6 months. Thank you.
Thank you, Bo. We have time for a couple questions while I invite Pat and the students to come on up. But in the meantime, any questions for Bo?
I just had a quick question. I was wondering if the predicted its undo of commissioning camera is, exactly 1/21st of the full LSST camera, or if it's greater or less than that.
Well, the integration time is quite different, right? So in order to make an estimate for the commissioning camera, you have to take into account how much time you will be observing with the commissioning camera. And then other than that, so to the first order, there's the integration time and the field of view. Apparently, that's another factor. And I don't think there's other.
I think the short answer is no. It's undo per unit time of Comcam is 1/21st that of LSST. It's not true because
So some compromises have been made on Comcam. People should be aware of this. So we are using an engineering raft. It's representative of one of the science rafts, but it's not of the same quality. You should be expecting that Comcam is going to be as the same quality as the full camera. Secondly, it has independent lenses, independent filters that were made specifically or being made specifically for Comcam. And those, we already know, at least in one case, will not be exactly representative of the full camera. So I think the way to think about Comcam is it is representative performance. It's a great pathfinder. But do not extrapolate from Comcam performance to what the full camera will do by multiplying by a factor of 21. That would be underestimating the performance of the full camera.
Okay, let's take it away. Great. So this year, for the first time, we have a number of undergraduates joining the LSST Project and Community Workshop. And this has been enabled through the LSST Corporation funding their travel and accommodations to be here for 2 days. So they arrived yesterday and had a tour of the Mirror Lab this morning, which was wonderful. And you should envy them for the tour. And what they're going to do now, there are posters that, actually your posters have been moved right in front, so that's great. So right after this session, for 1 hour, they'll be at their posters. There are 18 posters out there. And they're going to give a very short pitch on each topic so that you know which one you want to hit first, okay? So I highly recommend that you go out and talk to them about the research that they've been doing for approximately the last 8 weeks or so, some of them a little bit longer, and they are almost all undergraduates working on LSST-related research. So, and I can use this. So first, Nicole. You can step up, steer your thing, and then just step back.
Hi everyone, my name is Nicole Arredondo. I study physics at Grinnell College, and this summer I've been working at Fermilab Center for Particle Astrophysics. My research is focused on implementing cross-correlation techniques on galaxy and galaxy cluster catalogs. We used LSST Proto-DC2 simulated galaxy catalog, as well as the dark energy surveys year 1 and year 3 data. Our cross-correlations have found that there is leakage in the photometric redshifts, which basically means that there are associations between galaxies and clusters in different redshift bins. This has significant implications for cluster membership assignment, as well as may help us find a new way of determining a correction that's used in cluster mass measurements.
Thank you. Great.
Hi, I'm Rachel Butchery from Drexel University, and my research is about calculating the time and flux shifts between observations taken in different filters. And so I tested a bunch of mathematical methods on simulated data at different cadences and found basically that these methods performed well when you had daily observations, but it only occasionally worked for the suggested wide, fast, deep, and deep drilling field cadences. If you'd like to learn more, come by my poster.
Hi, so I'm Nick Easton. I'm a student at Case Western Reserve, and I've been doing research with Adam Miller and Aaron Geller at Northwestern. I've been looking at variable stars and trying to build a Zooniverse project which allows for citizen scientists to come onto the platform and classify using plots like this. They are met with plots, and then they give it one of 5 different classes, and we're trying to do this to build a training set of a couple thousand sources for machine learning for when LSST comes online and we have much more variable stars. Yeah.
Hello, my name is Alessa Ibrahim. I'm a senior in physics at Cal State San Bernardino, and I've been doing research at Stanford University this summer. What I've been working on is what we call density split statistics, which is briefly splitting the sky into different patches of densities, and to see if dense galaxies or galaxies that have high redshifts, to see if they follow what we call a Poisson distribution. And we also want to see if denser galaxy samples can help with, like, if we can get denser galaxy samples to improve cosmological constraints. But what I was working on is to see if at higher redshifts they followed Poisson distribution. But what I figured out is that the higher the redshift of the galaxy gets, the more it gets to a Poisson distribution, but it changes on different galaxy redshifts.
Hello everyone, my name is Miriam Juan, and I attended Cal Poly Pomona, studied applied mathematics. And this summer I worked at SLACT. I worked alongside the commissioning camera team, and I did some data analysis on the science drafts. So I looked at some of the data on the CCDs and electronic boards, and my main topic or research question was really looking at the thermal resistance circuit that is on the, that represents the temperature and the relationship to the power of the raft. And so what we wanted to know was how much of the power was leaking to the CCDs, and if the requirements that the raft has, did it meet the specific requirements in terms of it was temperature stable throughout the process of testing of the rafts. So, thank you.
Hey everyone, my name's Dylan Hillegas, and I study astrophysics at the University of Delaware. So the main goal of my research this summer was to compare various LSST observing cadences by testing various scientific cases by running those databases. We've basically found out that the baseline observing strategy outperforms the other tested strategies, but it all really depends on what scientific case that you are testing.
Hello everyone, I am Amber Lennon. I am a graduate student at West Virginia University. This summer I had the pleasure of working at Fermilab Center for Particle Astrophysics. My research focused on determining if it was necessary for the host galaxy of a merger event to be in the search galaxy catalog when measuring H0. We used the full sky log normal astrofield simulation kit and the GW170814 LIGO sky map to calculate the likelihood of H0. And we found that when calculating the likelihood, it varies little as a function of the galaxy bias.
Hi, I'm Nico Linton. I go to West Valley College, and over the summer I worked at SLAC for the refrigeration system. And on the refrigeration system, I helped build a cold compressor cabinet, as well as create a procedure on how to create the rest of the cabinets. I'll be excited to tell you more about it at my poster. Thank you.
Hi everyone, I'm Dorsa Majidi. I'm a transfer student from junior college, and this fall I'll be attending UCLA where I will study physics undergrad. And this summer I was fortunate enough to work with Dr. Burkhat and Dr. Rudman, and we investigate the size and shape dependency of LSST optical PSF on sensor height and incoming field angle. Our research also provides important quantitative information on relevant to stringent LSST requirements on sensor flatness. I look forward to discussing more about our research with you during the poster sessions. Thank you.
Good evening, everyone. My name is Kirsten Manahan, and I'm a rising senior at San Diego State University pursuing a Bachelor of Science in Applied Math. So this summer, I spent my summer at the SLAC National Accelerator Laboratory, and I studied the role that RTDs, or resistance temperature detectors, play in the cryostat refrigeration system of the LSST camera. I also investigated how to show that the RTDs that I was working on were in fact a reliable source of temperature measurement. On the schematic on the right is of the cryoplate, which is inside the cryostat, and the darkened rectangles are the RTDs that I was working on. So if you'd like to learn more about my research, feel free to stop by my poster. Thank you.
Hi everyone, I'm B. Martin from Drexel University. My research this summer concerned developing a method to accurately predict the redshifts of quasars using LSST's data. That's obviously a very broadly phrased question, but a large part of it was comparing a Nadarai-Watson Gaussian kernel regression to 4 of DES's, that's the dark energy surveys, photo-Z methods that they developed for galaxies. And we showed that our method compares favorably to theirs for both high redshift and low redshift quasars. If you want to hear more about that, come see my poster.
Hi, I'm Ethan Marks. I'm a rising senior at Northwestern University, and this summer we worked on developing a machine learning algorithm to classify supernova based solely on their photometry. But one issue with this is that even the most well-observed supernova have large gaps in their data. So we needed a reliable method. An intermediate step was to create a reliable method to interpolate the missing data. So we determined that using Gaussian processes, which is a Bayesian approach to modeling, was the best option. So if you'd like to hear a little bit more about how I got to my results or how we're going to use machine learning in the future, stop by my poster. Thank you.
Hello everybody, my name is Christopher Mortensen. I'm a rising junior at Northwestern University, and this summer I was working with Dr. Adam Miller and Professor Raffaella Margutti to answer the question, should LSST be used in kilonova discovery following gravitational wave events from LIGO? So one of these dense plots is just a snippet of some of the simulations that we have done, and essentially answering the question, if we, under the assumption that most kilonovae behave like the one that was discovered August 17th of last year in the binary neutron star merger, LSST will be vital in kilonova discovery. So if you wish to know more about what a kilonova is and why LSST should observe them, stop by my poster. Thank you.
Hi everyone, my name is April Nuestro and I go to Chico State. This summer I am doing research at SLAC for Stanford University on the LSST camera. And my primary concern is to figure out how we can get data from the CCD images. For example, in this image, I have an image that my grad student that I work with has projected onto the CCD. And it's an array of spots, and they're supposed to be a square of spots, but at the edge of the sensors, we can see that it's actually not detecting it. But I was able to locate those spots, and here it is.
Hi everyone, I'm Jack O'Donnell. I'm an undergraduate at the University of Chicago. This summer, I had the pleasure of working at the Fermilab Center for Particle Astrophysics with Jim Annis and Yuanyuan Zhang. And I've helped develop a high-performance C++ module for quickly and efficiently generating predictions of expected numbers of galaxy clusters and their stacked weak lensing profiles for a given cosmology. The past couple of weeks, I've been validating our module as it is now mostly working. And most of that has consisted of investigating the ways different people account for neutrino masses and the expected numbers of galaxy clusters, which is the plot that you see there. And in the next couple of weeks, we hope to get that finished enough that we can duplicate an existing analysis to compare how our code works, and then continue to investigate the more complicated parts of our model. So if any of that interests you, come talk to me. Thank you.
Hello everyone, my name is Karen Perez Sarmiento and I'm an undergraduate student at Macalester College. This summer I did research at Fermilab, Center for Particle Astrophysics under the supervision of Jim Annis. Part of my summer project was to study the prospects of observing binary neutron star merger events during the science validation surveys of LSST. It turns out that during those 80 nights of the science validation surveys, we might observe as many as 13 events. And following up with a few of these events might help us devise better plans for when the main survey starts. If you're interested in electromagnetic follow-up of gravitational wave signals, come see my poster. Thank you.
Hi, I'm Kazia Shallon. I'm from Drexel University, where I work with Gordon Richards. And my research question is about characterizing the bias within quasar samples. So the idea is that if we can better characterize what a quasar spectrum will look like throughout the entirety of the quasar population, we'll have a better chance of properly representing the quasar population. My work has been putting together spectroscopic data from the Hubble Space Telescope and the Sloan Digital Sky Survey to be used with an independent component analysis. So far, ICA looks like a pretty promising way to characterize the quasar spectrum and also kind of place it within the entirety of the quasar population so we can better understand, kind of give us a better intuition, for example, when we're trying to differentiate between like a star and a quasar, when it can be a more subtle kind of art. Thank you. If you have any questions, feel free to stop by my poster and I'll be happy to answer them.
Hi everyone, I'm Noel Stasiak, and this summer I spent at SLAC and I assembled the quadrant box for ComCam. The quadrant box is obviously a box that houses all the electrical components for ComCam, and the one on the left is the structure I built, and the one on the right is the quadrant box with all the electrical components in it. Thank you.
Okay, that's it. So 18 slides, 18 posters out there. And I want to just emphasize that this was the LSST Corporation who enabled the students to travel here. And hopefully we'll have the money that we can have another call go out this fall for proposals. So if you think you would like to have your undergraduates in the future come, then look out for that call, okay? And I'd also like to thank Gordon Richards, who helped organize this, he's over there, and Lyndon Hickey, who did a huge amount to help organize the travel for the students. And they will be here through the reception tomorrow night, and then leaving mostly Wednesday morning. So look out for them for the rest of the day today, and tomorrow through the reception and everything and say hello to them. They'd love to talk to you and about how you chose your own career and your career path too. So thanks.